Now we're going to hear from Lee Tate, who is a marine ecologist at NIWA, and he's going to talk about the impact of the extreme weather on coastal marine systems.
Kia ora koutou. Thanks everyone for turning up for this meeting. So the project that I'm leading starts to look at some of the potential impacts that these events, these large flooding events, have on our coastal ecosystems. So this Sentinel-2 satellite image really shows what these sort of events mean for our marine environment. All of the sediments and material that is mobilized during these flooding events eventually ends up in the ocean. So this has a particularly broad range of impacts on our coastal marine ecosystems. Clearly from the sediments, which have a really key role in blocking light, reaching the seafloor to a huge range of plants, marine plants that fix carbon and provide a range of ecosystem services. What's not shown particularly well in these images is how these events become a legacy event. So you can see from this image taken a number of months past the event is still outputting a huge amount of sediments into the coastal marine environment, and the deposited sediments will be there for a long time afterwards, either being resuspended by wave events or moved along the coastlines. So there's a range of ways that these extreme events can impact these ecosystems. They can bury rocky reef habitats where a lot of organisms live. The suspended sediment blocks light to the seafloor. It can smother and bury things. There's obviously the risk of contamination as well associated with other stresses that have entered the marine environment during these events. All of that fresh water can cause mortality of a range of different marine species that require that saline water to survive. And as we've seen, associated with this event is a large amount of debris into the marine space, which can have physical scarring and can destroy a range of organisms. So clearly there's a lot of things at risk, and one of them is a broad term of ecological services. And obviously these ecosystems provide a lot of services, not least of which is carbon sequestration and removal from the atmosphere. There's also numerous fisheries that rely on these ecosystems and traditional practices of kaimoana harvesting. And with that, I'd like to really acknowledge Maunga Haruru Tangatu Trust, which is a iwi and hapu collective based in Hawke's Bay, which have really suffered dramatically during this event. And we actually had a project with them in November 2022, which has set up a really amazing baseline for us to understand what this event has done to some of their cultural treasures, some of their taonga species. And also we have other partners, University of Waikato and University of Canterbury, that are contributing to understand the impacts of this event over really broad scales. So the plan of our research is first and foremost to repeat some of that sampling, that baseline work that's been done along the Hawke's Bay coastline to Tairāwhiti, having a look at a gradient approach away from some of these major catchments, for example, the Esk River. So in this environment, we have baseline studies that cover a reasonably broad geographic area that will allow us to infer a lot about other areas. But the plan is to also use gradients away from these catchments, these main catchments, to identify what these impacts have likely been where baseline information doesn't exist. So yeah, there's a range of tools we'll be redeploying from aerial drones, towed and remote operated cameras, as well as really leveraging the satellite imaging platforms that exist and will give us some detailed time series information. I did mention our partners. I will just lastly note that we are actively engaging a range of additional partners, particularly up into at the regional councils of Hawke's Bay and Tairāwhiti, and we're also looking to really shift some of the work up towards Tairāwhiti as well, and make sure that we're covering a fairly large portion of this complex and challenging coastal environment. That's me. Thank you very much.